I will continue once again the yesterday's class which was continued. Am I audible? Anybody acknowledge me? Am I audible? Actually, today I thought of taking the compilation expression but due to network issue, let me continue the same because yesterday we had through 2 to 3 interruptions in the class. Hurry up to join the class. So let me finish. Sorry, let me start up while the students will be joining the class. So yesterday I was supposed to show one of my notes. What are the content of the? This is a black picture from my notes which I have taken. So I would like to present the screen. So this is the figure, not figure. This is the one which I was explaining yesterday. This image I have taken from my notes. And am I audible? Anybody? Am I audible? So yesterday I was been telling you about the AR activation record and what is this activation record. The basic hint also I have given you. Actually, we were studying in the past last week class. From the last week class, we are studying about the compilers and mainly in compilers, we have to know in compile whenever we say compilers means it is all about the high level language. So the compiler means it accepts the high level language and convert it into machine language. That is the low level language, which is nothing but the assembly language. And further using the different phases of the assembler codes, code optimization will happen, and the go after the code optimization, and we can see the final object code generation, and we can see the that object code with whatever it is generated, which is nothing but given to the loader, and sorry, it is given to the linker and loader to load in the memory. Those are the next different stages of the compiler, sorry, of different system softwares. So up to the compiler, we should understand that it converts it into assembly language. That assembly language, which is a target language, which is a object language. So that object language till there are the phases of the compiler. What the phases of the compiler does, every phases of the compiler have got their own individual responsibility. But here we need to show the responsibility for the compilers in terms of the source code. In the source code, there will be the high level, there will be the different data items and different data items or the variables or the objects in the source code, and those variables and objects in the source code, how they are they are used, not how they are used. A programmer will make use of those objects or the variables or the source code for writing the target of the program, or for writing the project, or for to seek the project aim. So those source codes will have the variables or the objects. Now the question is that how the compiler will store those variables and objects in the memory. Of course, it is actually given in the Am I audible? Am I audible? Okay. I hope I am audible. So for the data variables, for data items, we are going to allocate the memory allocations. And these memory allocations are of two types. That is the static memory allocation and of course the dynamic memory allocation. You know very well the static memory allocation. The allocations which is fixed, the location which is fixed, and here the data does here the memory doesn't change throughout the runtime of the program. And stack belong to the dynamic memory allocation, and the heap also belong to the dynamic memory allocation, and in stack follows the method of the LIFO, and here stack indicates for the number of procedures used in the program. The number of procedures contains the data items or the data variables of the data items or the data variables of that particular function, which are useful for deriving or for performing that particular function in a program. If there are n number of procedures, so n number of records are maintained in the stack. Here procedure indicates the record, and I have shown you in the previous class the stack format also, which is nothing but the record format used in the stack. So record format which is used in the stack also we have seen, and if I want to show once again, so again I think it will support or not, I do not know. Onkar, are you there? You are listening to my class?
जी मैडम सुन पा रहे हो
क्योंकि कोई भी नहीं बोल रही है. Am I audible or not? Okay.
हाँ सुन तो पा रहे हैं लेकिन आपकी आवाज काफी धीमी से आ रही है
आवाज.
आपकी आवाज धीमी से आ रही है
अच्छा.
और रुक भी आती है बीच बीच में
एक्चुअली मैं कॉलेज में नहीं हूँ. So we are talking about the AR activation record, the stack. So for the stack storage allocation, stack itself is nothing but a default data structure, and you know very well that the last in first out. Now here, who is going last in? Sorry, who is? What are the elements which are entered in the stack? It is nothing but the procedures which are used in the program. Who are those procedures? Those procedures are nothing but your functions, what you do for the programming, for your program to execute. So those are the functions or the procedures which are used in the program. It is stack stores whatever the number of procedures are used in your program. Those many number of procedures are stored in the stack. How is the format of the stack? Here format downloading, again I may lose the memory. Sorry, again I may lose the bandwidth of the internet. So I will, for the same figure, I will just tell you how is the format of the record. How is the format of the record? Now here record indicates the procedure, and each record is nothing but that is nothing but a procedure, and the procedures named here something like A and something like B. And if you remember, I have told you that in the previous class, some figure I have used, ABC figure, the block A, block B, and block C, and C is having the ancestors of A and B, and C is nothing but the block sub block in sorry, C is nothing but a sub block, B is also sub block, and A is also sub block, and all these sub functions which are nothing but used in the main program. But how is the sequence of the program in the sense? The sequence of the program is something like that. The uh, the sequence ABC is the sequence of the program. So first A procedure is entered into the block, and B is entered into the block, and C is entered into the block. So the C program becomes the last in, and but it is ready to execute at the first. So that is what the data structure which is used here for this dynamic memory execution, for the dynamic memory allocation of the C. So here C has to execute first, and here W and Z are the local variables for the C, and for the local variables for the C. And if you remember, how was the declaration? X was declared to A, and Y was declared to B, and Z and W were declared to Z and W were declared to C. And Z and W here, it is acting as the non-local variables to the block A and B, to the block A and B. And Z and W are local variables to the C. So now the question is that how the memory will get allocated for these local variables. So the memory will get allocated only during the active time of the blocks. So what is the active time of the block here? Am I audible, Onkar? Anybody acknowledge me, or should I have to come back to the window? Am I audible? Giteshwari, am I audible? Vivita, Kajal, Sonia. Okay. Are you listening to the class? I'm just showing here the
Ma'am.
activation record. Once again, I'm showing here each activation record indicates the procedure, and these how many procedures are there in the program. So those many procedures will be built onto the stack, and how the stack takes the sequence in the sense based on the sequence of the program. So here, based on the sequence of the program, here first A has to get into the stack, and B has to get into the stack, and C has to get into the stack. And if you remember, I have told you that for each activation record there are two pointers, first pointer and second pointer. First pointer points to the non-local variables, and the second pointer points to the points for allocating the next sequence of the activation record. So here we have the three procedures, and in these three procedures the C is ready, which is alive, and B and A which are not alive. So the moment C is getting begins to execute, it starts generating the memory for Z and W, and it performs its execution, and this C will be popped. The moment C is popped, the top of the stack will be pointing to the Y. The top of the stack will be pointing to the Y. So Y is nothing but a local variable which belongs to the activation record of the procedure B. So Y is a local variable for the procedure B, and this Y local variable, using this only, it returns whatever its value to this local B and executes. The moment it executes, it will be popped, and the top of the stack will be pointing to the activation record of the variable called as the X, and this X will be allocated, which is nothing but called as alive. So in this way, the activation record maintains the data structure, and you will know that it is in the form of this. It is the stack format, so it follows the stack rules. So that is what the activation record is, nothing but it preserves all the procedures of the program. So preserves the procedure in the sense it starts storing the memory, allocate it, it starts allocating the memory. Now here for the next, what I was saying in the yesterday's class. So how the activation record does or begins its execution. The activation record begins its execution because here each activation record contains the local variables, so that they are bound to the fresh storage in every activation record. So here each activation record has got the 7 contents. I was been telling you in yesterday's class also. Who are those 7 contents? This note I have picked from my note. Look into these 7 contents. It is nothing but the actual parameters and the return value, actual parameters, return value, and the access, control link, access link, saved memory status, and also the local variable and temporary variables. So these are nothing but the contents of the activation record. Now the content of the activation record, how does it executes each procedure? How does it executes each procedure? First, the actual parameter. What is there? The actual parameter which corresponds to the formal parameter of the procedure. The actual parameters which corresponds to the formal parameter of the procedure. Now here Z and W. So this Z and W, which are the actual parameters, also corresponds to the formal parameter. Maybe there can be something like A and B. So these formal parameters, which are nothing but the parameters which belong to C, and they will have one return value. So here that's what we have in activation record. If you see this 7 contents of the activation record, it is having something like a return value. This return value is used by the calling procedure to return a value to the called procedure. To return a value to the called procedure. So after computation, it will return the same function, or the procedure will return a value to the called procedure, whoever has been called. So next, how does it makes the how does it makes the, I mean, caller, that is the invocation. It points to the activation record of the caller, means invocation. Here how does it maintains the makes the invocation, means using the control link. And there is also a access link. It is used to refer to the non-local data which are held in other activation records. So there is also a link which is that link which refers to a non-local data. Now if you go with this data, which data in the sense, now W. Now W is a non-local, and Z is also non-local to procedure B and A. So here to access this Z and W, we can use also a access link. So that access link can be used to access the non-local data items, also data variables. So that is nothing but the third content of the activation record. The third content of the activation record says that there should be an access link. Not third, it is the fourth content of the activation record. It is used to refer the non-local data or the variables held in other activation records. Now the saved, yes, hello, wait. Now the next is the access, the next is saved machine status. The saved machine status, which is having the information of the status of the machine. That means a program counter will hold the address or the instruction of the next statement before the procedure is called. So that is how it is having the another content, that is the fifth content. And the local data is nothing but the local execution procedure, which holds the data which holds the data which are of the local. And there is also temporary variables. These temporary variables which are used in the sub procedure. So those sub procedures which are used in the sub procedure are the same function. Say for example, during the swapping also we use some temporary variables. So those temporary variables also should need to be allocated to the memory, and afterwards it should be released. So those are the variables which are used for performing or evaluation of the executions. So for them also the data or the memory is allocated. So next is, yes, am I audible? Am I audible? Yes. Omkar, what are the contents of the activation record? Did you got? Yes, Sonkar. Can anybody answer me? What are the contents of activation record? Onkar, Sonia, anybody please answer no. Are you listening the class or not? Prashant, Abhishek, Gauri, Yogesh, what are the contents of the activation record? Yes, Onkar, can you answer? Vivita, okay, the contents of the activation record are 7 contents. Those contents of each activation record, you know very well that these each activation records are used for each procedure, and each procedure has to come across all these contents of the activation record to execute the procedure. Now, now let us look into that uh, example. This example. Now, if we want to execute the procedure C has to come across with all the 7 contents. First, it has to check out its actual parameters. The actual parameters are Z and W, and Z and W it is used by calling procedure to supply the parameters to the called procedure. And next, it has to look into the return value. So, the return value will be computed by the procedure to return the calling procedure. And next is the control link. The control link will ask the activation caller what it is used in order to the records. Next is as sorry, there is some other variables we variables that may be useful for me while executing the procedure C. And the saved machine status. It is used to hold all the informations about the activation record or about the status of that currently running procedure. And the local data are nothing but used to hold the information about the local data to execute the procedure. And the temporary variables, the variables which are used for executing any any procedures. So it stores, so temporary variable will store such values that arise in the evaluation of the executions of that procedure. So every record has to come across these seven contents. And activation record is used to manage overall. The activation record is used to manage the information needed by the single execution of a procedure. Single execution of a procedure. And one more thing, the activation record which controls, the activation record which is nothing but a record which is controlling the runtime of the stack, which is used to keep the track of the live procedure activations, which is used to keep the track of the live procedure activations. When the activation begins, the procedure, it is something like how do they get popped, how do each activation will get popped. So how we can reach the other activation records also. When activation begins, the procedure name will be pushed into the stack, will be pushed into the stack, and then it returns a active, when it returns to an activation end, so it will be popped, it will be popped. So in this way, this is all about the activation record. Onkar, did you got? Now next it will be the heap. The next it will be the heap. The heap, it is also nothing but the heap. It is also nothing but here I have taken from the textbook from your Dhamdre. Heap, it is also nothing but, as I said yesterday's class, it is also one of the data structure, and heap is such a data structure where we can any place in the program you can allocate and deallocate. How you can allocate and deallocate? You can allocate and deallocate by using the keywords like calloc and free the function, or free the memory, whatever. So by using the calloc, malloc, there are different, the functions which are used to allocate the memory for any variables or functions. So or full procedures also. So that time you can anywhere, any place in the program you can allocate or deallocate. That is the speciality of the calloc. Sorry, that is the speciality of the heap. Heap is a data structure same as of the stack. So here in this example, before going to that example, one more I would like to show here. The declaration part, what we have done here for the declaration part. So here something like float first pointer, and the second pointer is used, and you know very well that for pointer we need to designate them by 2 stars. So here I have the pointer variables 1 and 2, and also I have another pointer variable which is of PTR, which is an int data type, integer type. So totally I have here 3 variables. First two variables are floating variables, and the second variable is a integer pointer variable. So among these variables, all the variables, the floating, the first 2 pointers, which are of the floating values, so those are allocated as the calloc, means only during the runtime of this procedure, wherever these pointers are used, they are only used, and those values also are given 4 and 5. And here I have something like another pointer, the integer pointer, and this integer pointer is also made as the calloc. which is nothing but allocating the memory, and which is nothing but allocating the memory, and the value is also given here as 10. And here we have told here that free the pointer 2 after using the pointer 2, after using the floating pointer 2, we need to free this. We need to free. And it shows that pointer, integer pointer and float pointer are not released their memory, are not released their memory. Soon after runtime, it is here in this line, not soon after their runtime. In this line, when the current, when the pointer comes currently to the, or when the location counter comes currently to this line, where that time the second pointer will be not in use. The second pointer is no more used. So that is what it is made here as free. So such an example it is so here what the values which were given. The values which were given something like 5, 4 and 20. So here the floating pointer which is having the value something like 20 and something like 60 and integer something like 40. But here which area was freed? The area which it has to get free for the pointer like second pointer. We have told the second pointer should be freed while running the pointer 1 and integer pointer. So that is what it is made here the holes. That is what here it is made as hole. So if you observe here, so the free area is here and also the free area is here. So that is nothing but how we can during the execution time whenever we want or whenever in the program at any place anytime we can free. So to identify the free areas in the memory, we can use another two techniques, that is reference count and garbage count. So this reference count and garbage count. So here let me explain once again if you want. So the float pointer 1 and the float pointer 2, which are nothing but the floating points, floating point variables. And if you see the statements from 3 to 5, it starts allocating the areas of the memory to accommodate the 5 floating point numbers and also the 4 pointing numbers. And when it comes to the variable called as the integer pointer, so the integer pointer will have the integer value, and as shows in the figure, we have used the values here, the 20 and 16 for the second pointer and 40 for the third integer pointer. And when you observe the code, so in the code at any time we have told here that to free, what to free, the second pointer to be freed here, the second pointer to be freed. Therefore, it shows something like this. The second pointer here it is freed. Who was the second pointer? The second pointer was the floating pointer, the floating value pointer, which how was the variable name? Something like FLOAT PTR2 was the second pointer, and its memory is freed here. So, likewise, we can also detect some other free memory areas in the memory by using the reference counter and garbage counter. Now, what is this reference counter and garbage counter? These two are the techniques which are used to identify the free memory areas. Okay. So the reference counter, what it does? This reference counter, as the system associates with the reference counter, it means each memory area is used to indicate how many users of the programs are currently using it. So you can also guess it by using the count. If you press the system configuration, there also you come to know how the memory is being used and how many programs are running. The count indicates in the count here indicates that the number of programs or the number of users gains the access to the area of the computer, that is the memory of the computer. So that shows whether the memory is free or not. Means there also it indicates sometime the memory is running out of bound. Whereas the garbage collector makes the two passes. This garbage collections, it is also used to detect the free memory in the in the RAM. So it does in such a way that it will be having some two passes. In the first pass, it traverses all the pointers that points to the allocated areas and marks that the memory areas as in use. And in the second pass, what it does, it finds all the areas that are unmarked and declares them to be as unsaved and declares them to be as unused or not to use, or it declares them as free them. So by saying as free them, so that makes as the memory to not to be used. So in this way, it saves the memory area. So during this feeling, you can check it out during the system configuration when you come to know at the desktop. Also, you will be coming to know how to check the memory, how much it is in use also, how much it is in use also. So in this way, you can check it out. The memory is how far it is used by the computer. So nothing more on this much only. I think I have taken a lot more on this. So let me ask you a question. What are the content of the AR? I simply am going very repetition. It's more enough to be told on. I think I have told 4 classes. 2 hours means it's a 4 classes. So it's a big, mm, and all the students. It's a big number of class. So Onkar,
जी
Sonia, yes, have you understood? AR,
जी
what
आया है
is
सब।
activation record? What are the content? Can you name anybody? Just
और
now I have
एक्चुअल पैरामीटर और
yeah, yeah,
लोकल इनलाइन डाटा,
yeah,
सेव्ड मशीन
very good.
स्टेटस सेव
Mhm.
करेगा। एक्सेस क्लीन जो पॉइंटर और कॉलिंग के बीच में प्रोसेसर है उसको पॉइंट करेगा। एक्चुअल
Yeah.
पैरामीटर्स।
Mhm. Very good. Because of you only, I have taken one more class. Otherwise, nothing is there in that. And each activation record represent what? Can anybody tell? So that whatever I am telling you, whether you are understanding or not, most of the students they join and they go off, and they are not even concerned also bothered. Hmm? Yes, can you tell anybody why only always Onkar has to tell? Prashant, Yogesh, Abhishek, Rasika, what each activation record represents? Simply I'm going on my own way, and this is the fourth number, fourth R. Can you tell Akshada, Ahilya? Each activation record represent what? Sonia, at least can you answer? There is no meaning simply shouting on my own way. Madhura, Prashant, Gauri, Rasika, Naveen. Naveen, can you tell? अभिषेक मौलिक, कैन यू टेल? एक्टिवेशन रिकॉर्ड होता है क्या? और हीप में क्या होता है? हीप स्ट्रक्चर में। अच्छा उनकर आप ही बोलिए। हीप स्ट्रक्चर में I have taken one example also. Whenever we want, we can free it. In the same example, I told at this after the declaration to free the second pointer. So that's what after the heap, the second pointer, how it was freed. So here if you observe how the second pointer was freed from the memory area. But pointer 1, float pointer 1 and integer pointer are in use. This is what after the heap. Yes, Onkar, आप ही बोलिए. Each reactivation record represents what? Hmm?
और जिन जिन प्रोसीजर का एग्जीक्यूशन कंप्लीट नहीं हो पाया है उसको स्टैक में लेगा और उसको पॉइंट करते करते वक्त उसको कंप्लीट करके लेगा.
जिन जिन एग्जीक्यूट नहीं होगा. हाँ हाँ.
नहीं, मैं बोला कि जो जो प्रोसीजर एग्जीक्यूट नहीं हो पा रहे, प्रोसेसर बोला
हाँ
मैं, उनको स्टैक
हाँ
में लेगा और एक एक करके
हाँ
कंप्लीट करके लेगा.
हाँ हाँ.
फंक्शन को कॉल करते करते एग्जीक्यूट करके
हम्म,
लेगा और फिर प्रोसीजर
हम्म.
कंप्लीट होने के बाद वैल्यू रिटर्न करेगा. इसके लिए तो वो जो 7 कंटेंट्स है उसमें रिटर्न वैल्यू, एक्चुअल पैरामीटर जो
वो
फॉर्मल को
इसके
असाइन
लिए
करके
है.
देगा.
हाँ हाँ.
जितना मुझे अंडरस्टैंड हुआ है, जितना समझ में
यस
आया है,
यस.
मुझे पता.
पहले क्या करेगा, जैसे ही सीक्वेंस ऑफ द प्रोग्राम है, वो जो भी सीक्वेंस है, सोचो कि प्रोसीजर ए है पहला सीक्वेंस, और सेकंड सीक्वेंस प्रोसीजर बी, थर्ड सीक्वेंस प्रोसीजर सी. ये जो भी है वो सीक्वेंस का डेटा स्ट्रक्चर में डालेगा, और जो भी लीफो के फॉर्मेट में आएगा, फर्स्ट सी को एग्जीक्यूट कर लेगा, और वो सी को जब एग्जीक्यूट करता है तो सभी प्रोसीजर्स क्या करता है, उसका कंटेंट को बुला लेता है. उसका कंटेंट क्या रहता है, 7 कंटेंट्स. वो 7 कंटेंट के हिसाब से वो एग्जीक्यूट कर लेगा, और एग्जीक्यूट करते ही उसको पॉप कर देगा वो प्रोसीजर को, और नेक्स्ट प्रोसीजर रेडी हो जाएगा एग्जीक्यूट करने के लिए, और वो भी वैसे ही फेस करेगा 7 कंटेंट का. और हीप वो तो बहुत इजी है. जब चाहे कैलॉग कर सकते हैं, जब चाहे फ्री कर सकते, किसी कोई भी डेटा को, कोई भी ऑब्जेक्ट को, कोई भी वेरिएबल को, कोई भी फंक्शन को जब चाहे हम फ्री भी कर सकते हैं, और जब चाहे हम अलोकेट भी कर सकते हैं. ओके. अच्छा है आपका अंडरस्टैंडिंग. आप सुन रहे मेरे क्लास को? यस. अदर स्टूडेंट्स? प्रशांत. प्रशांत. 1, sorry for again the connection was lost. 1, 2, 3,
Ma'am, one is present.
2, 3, 4,
Four present.
5, 6,
6 present.
7,
Seven
8,
present.
9,
Present, ma'am. Rule number 9.
10,
Present, ma'am.
11,
Present, ma'am.
12,
Present, ma'am.
13, 14, 15, 16,
Present, ma'am.
17, 18,
Present, ma'am.
19,
Present, ma'am.
20,
Present, ma'am.
21,
Present.
22, 23, 24, 25,
Present, ma'am.
26,
Present, ma'am. 26.
27, 28, 29,
Yes, ma'am. Present.
30, 31, 32,
32 present.
33,
Present, ma'am.
34,
Present, ma'am.
35, 36,
36 present. 35 present, ma'am.
37, 38, 39,
39 present, ma'am.
okay, 40, 41,
Present, ma'am.
42, 43, 44,
Yes, ma'am.
45, 46, 47,
Yes, ma'am.
48, 49,
Present,
50,
ma'am.
51, 52, 53, 54,
Present.
55,
Present.
56,
Present.
57, 58, 59,
Present. 59.
60, okay, 60, 61, 62, 63,
Present, ma'am.
64, 65,
Present.
66,
Present.
67, 68, 69,
Present.
okay, 70.
Present, ma'am. Roll number 3, present, ma'am.
Wait, I'll read out. Okay, 2 is present. 3, 5, 8, 13, 14, 15, 17, 22, 23, 24, 26, 27, then to 30, then 30, 40, 42, 43, 45, 46, 47, sorry, 46, 51, 52, 53, 61, 62, 64, 67, 68. These are the absent.
Roll number 3, present, ma'am.
Ma'am, roll number 8.
5 present. 51 present.
When are you,
Roll number 20.
wait. When you people will perform your demonstration, can you perform now? Is there anybody student ready with your desktop? Can you share your screen of executions of the program? Sonia, Sonia, Ashru Bhore, can you share? Kajal, okay, tell you who is present now. 2 is present. Next, Onkar, Onkar,
जी मैडम.
डोंट टेक्स्ट मी प्लीज. हाँ ओनकर बताइए क्या करना है. आपके साथी कुछ नहीं बोल रहे, कुछ नहीं कर रहे. ऐसे ही आगे जाना, पूछना नहीं, कुछ नहीं. स्टार्टिंग से बस आप ही इंटरेक्ट कर रहे हैं, आप इंटरेस्ट लेते हैं. आपने क्या करना है? पूजा, क्या
Yes, ma'am.
हाँ, तो कोच भी बोल रहे हैं ना, लैब रेडी नहीं है आपका प्रोग्राम?
मैम आपका वॉइस नहीं क्लियर से आ रहा है, ब्रेक हो रहा है।
अच्छा, Sorry, again the connection was lost. Anyhow, your C hash sir, I mean your coordinator sir, Jagdale sir has told that to leave you all. I don't know, I think some session is there for you all. So once again I will check out your absentees list. 3, 5, 8, 13, 14, 15, 17, 22, 23, 24, 26, 27, 30, 40, 42, 43, 45, 46, 51, 52, 53, and 61, 62, 64, 67, 68. These are the absentees list, and if anybody.
Roll number 3
Ma'am,
present, ma'am.
ma'am,
Okay,
22 present.
okay.
Ma'am, roll number 40 is present.
Hmm.
Ma'am, 42
It present.
also.
Okay. Hmm. Please come next time with your laptop and show your program. Each one of you should demonstrate. Otherwise, uh, it doesn't look good because there should be some practical you should do. Okay. So thank you all. Jagdale sir want you all the students to join for some other session. Sir will guide you where you have to join. Thank you all. Your class coordinator will guide you. Sir told me to leave you all. Okay.
Ma'am,
Tell.
824 present.
24.
Huh.
Okay.
14 present, madam.
Okay.
8 is present, ma'am.
Okay.
Ma'am,
Thank you.
hello.
Huh.
A46 is present due to network issue. She is unable to give presenting.
Okay. Thank you all.
Ma'am,
Please
can
follow
you
the. Huh?
recall the absent number? Can you
Huh?
recall the absent number?
I told how many? Okay. 5, 13, 15, 17, 23, 26, 27, 30, 43. You tell your number what?
Yes, yes, I have. Tell.
What's your number?
42, ma'am.
42 you told no to mark unabsent. I have marked.
Okay, okay. Thanks, ma'am.
Thank you all. Follow Jagdale sir, your class coordinator.